To the Algebra 2, section 4.1 notes, just the first half. So the first thing we're going to talk about is what is a polynomial function. So just in general, this whole chapter is about polynomials. So it is a function that is either a monomial, and a monomial, mono means just one single, so a single term, or a sum of monomials. And one key of it is that the exponents are all whole numbers. And whole numbers actually are numbers that start with 0. There's 0, 1, 2, 3, 4, so on. And the coefficients all have to be real numbers. So like no i's in there. Okay, you can pause that if you need to write it down. So we're going to build our chart here. So if it has a degree of 1, it is called a constant. And this format I always find is kind of weird. It's a sub 0, which just means the first coefficient. So I think the example is clearer. If you have like f of x equals negative 14, that's a constant function. Do you see how it's just f of x equals negative 14. So that means the y values are always negative 14. There's no x over here. Now, if it has a degree of 1, that would be a linear equation. And so what that would look like is you would have a1, which is just the coefficient, so a number in front of the x, plus a sub 0, which is just your constant. So like I said, I think the example is clearer. If you have something like this, where it is just the x is the only exponent, it's not squared, cubed, or anything else, that has a degree of 1, and that's called a linear function. So a degree of 2 is called a quadratic, which we've worked heavily with. And so, like I said, the standard form is just kind of weird. A2 just means the coefficient in front of x squared. A1 is just the coefficient in front of x. A with a little 0 is the constant. So the example kind of makes more sense. You could have like 2x squared plus x minus 9. So the highest power is 2, so the degree is 2, which means it's quadratic. If the degree is 3, it's called cubic. And so what that looks like is a3 is just the coefficient or the number in front of x cubed. A2 is the number in front of x squared. A1 is the number in front of x. And a sub 0 is the constant, the one without a variable. So, for example, you could have x cubed minus x squared plus 3x. You could have a constant there, or the constant could just be 0 like it is in this case. But notice the highest power is 3, so it's a degree of 3, which means it's cubic. And last but not least, if it's a degree of 4, that's called quartic. It's a quartic function. And so what that looks like is a sub 4 is just the number in front of x to the 4th, the coefficient, plus a sub 3, which is the number in front of x cubed, plus a sub 2, which is in front of x squared. A sub 1 is in front of x, plus a sub 0. So remember, if the coefficient was 0, like let's say, for example, if this a sub 3 was 0, then you just wouldn't see x cubed. So like if I use that as an example, if I had x to the 4th plus 2x minus 1, it totally skipped x cubes and x squareds, but that's okay. The highest power is 4. And so you find that right here. The highest degree is 4. So the degree is 4, and how we would call it is we would say this is a quartic function. Okay, so let's try this. It says determine whether each function is a polynomial function. How we know if it's a polynomial, it's different monomials, so different terms, adding or subtracting. The exponents are whole numbers, meaning 0, 1, 2, 3, 4, and so on. And the coefficients are real numbers, meaning not imaginary. So this one is a polynomial. You can see that we have exponents that are all real numbers. It says write in standard form. Standard form is the highest power down to the lowest power. So this is already in standard form because if you see the powers or the exponents go cubed, 1, and then the constant at the end. That's standard form. And we're going to put yes, it is a polynomial. Now it wants its degree. Its degree is its highest power, so the degree is 3. So if it is a degree, its type is called cubic, because 3 is cubic. And then it wants the leading coefficient. The leading coefficient is, once you have it in standard form, the number in front of the biggest power, so x cubed, the number in front of that is -2. So the leading coefficient is -2. All right, let's try this again. So over here on B, we have this is fine. All right, we can have decimals, totally okay. The exponent is a whole number. We can have a square root of 2 because it's only over the 2, not the x, so that's fine. That's a coefficient. We have x to the 4th and then -12. So this is a polynomial. So standard form, I'm going to put SF for standard form. So standard form, remember you write your highest power first, so that was this x to the 4th. So first we're going to start with square root of 2 x to the 4th. Okay, now go down to your next power, which is x cubed, so that's minus 0.8 x cubed. Then do x squared, then x, but both of those are missing. So now the constant goes last, which is -12. So that's standard form. The degree is the highest power. The highest power is 4. And so that means the type of it, when it's a degree of 4, is quartic. You can just look back up on our chart to tell quartic. And the leading coefficient is the number in front of the term with the highest power. So x to the 4th is the highest power. The coefficient of that is square root 2. Okay, let's do this again. So down here, we check first, is it a polynomial? So -x squared is fine. Here's where it's not okay. It cannot be x to the -1. When we talk about whole numbers are 0, 1, 2, 3, 4, 5, and so on. So -1 is not technically a whole number. Okay, it is an integer, but not a whole number. And so it is not a polynomial. And basically, the negative exponent is what causes it to be not a polynomial. All right, let's look at D. So D, the x squared's fine, but this 3 to the x is not okay. X is not supposed to be in the exponent to be a polynomial. So the variable in the exponent causes the problem. So we're going to say not a polynomial. So kind of heavy on vocab today. All right, example 2 is really easy. It says evaluate this function when x equals 3. So if you write it like this and you put f of 3, all that's saying is I'm plugging 3 into function f. F is just the name. So you do 2 times 3 to the 4th minus 8 times 3 squared plus 5 times 3 minus 7. And you seriously just type all of that in your calculator and you get 98. All this says is when I plug 3 into function f, the output is 98. Okay, in behavior is the other thing we're learning today. So in behavior, if it has an odd degree, remember the degree is the highest power. So if it has an odd degree, first of all, the shape for an odd degree is like this or like this, meaning that one end goes up and one end goes down. So if it's an odd degree, we know it's one of those two shapes, but if it's a positive leading coefficient, then what that tells me is the general format is it's going to be like, it's going to be like this one. So I'm going to draw it kind of like this, except I'm going to switch and do like dashed lines. So why I did that is because it could have any number of like loops in there. So it could kind of go and have multiple things like that. That'd be kind of wild, but it could. But the point is that as it goes to the left, it goes down. And as eventually, after it does whatever in the middle, it goes up. And so what this means, they write it in kind of a special way. They put f of x approaches negative infinity. That arrow means approaches. So all it means is the y values are going down as you go to the left. And how you write as you go to the left is x approaches negative infinity. So this top means the y values are going down as the x values are going left. So eventually you write out all the different waves in the middle, but eventually you're headed down as you go to the left. That's all that means. So then this means the y values are going to positive infinity. So it's going up as the x values are going to infinity. So all this means is as you're going to the right, that's what x to infinity means, the y values are going up. So as you go off to the right, after you write out however many humps there are in the middle, eventually you're going up as you go off to the right. So if it's odd, but it has a negative leading coefficient, it's kind of the same concept, except that negative is going to have reversed it. And so it could have any amount of like waves in the middle there, but eventually in behavior, in the end, it means that the y values are going to positive infinity as the x values go to negative infinity. So this just means it's going up as you go left. That's all that means. It's just in the correct notation. So the y values are going to positive infinity means they are going up as you are headed left. So then if you head right, you write out all the little waves in the middle, but eventually you're headed down. So this, how we write it, is f of x approaches negative infinity, meaning the y values are going down as you're moving off to the right. So this just means the y values are going down as you move off to the right. So even degrees look like this, and they can have any number of like little loops in the bottom. They can have like a lot of loops or just a couple loops. So even degrees have where they are either both going up or both going down. That's what even degrees do. And how you tell which one is by if the leading coefficient is positive or negative. So the even degree and it's positive, that means they're going up eventually. So it's like this. And then, like I said, there could be any number of kind of loops in the middle. But eventually, as you go to the left, it's going up. So this means the y values go up as x goes to negative infinity. All that means is the y values go up as you move to the left. So as you move to the right, you write out all of this, and eventually you're going up. So this side means the y values are going up as you are going to the right. That's all that means. So when it's negative, it's still where they're headed in the same direction, but this time they're headed down. And so, like I said, any number of like loops in the middle can happen. But this means the y values, that's f of x or the y values, are going down as you are moving to the left. And this means the y values are going down as you are moving to the right. But this is the notation you'll put it in. So this means f of x is the y values are approaching negative infinity. That means y values are going down. X approaches negative infinity means as you move to the left. So as you move to the right, if I follow the right, I go up and down, but eventually I'm headed down forever. So as I move to the right, I'm going down forever. So if we look at number 3 right here, it has a degree of 4, so it has an even degree. And that means, and then the leading coefficient is negative. It's negative 0.5. So what that tells me, if I look up at my chart at even and a negative leading coefficient, it looks kind of like this. So what that tells me, the end behavior is the y values, f of x, approaches negative infinity. They're headed down as you move to the left. And the y values are also going down, so approaching negative infinity as you move to the right. Okay, for the sake of time, here's example 4. I did a table in my calculator and I figured out the graph.